Today we have a very different chapter. We have drainage basins. We have successfully completed the module of physiography, where we have seen lots of structure in the form of Himalayas, plateau, coastal plains, island, and so on. This time, or in this module, we will try to see what is a drainage basin, how rivers gets originated from their sources, what is the pattern they follow. Fine. So you can relate with the figure of drainage basin. You can see there is a water divide. This is a colorful map also in the third page. There is a water divide. What does it mean? Water divide means it is at a high altitude as compared to your mean sea level, and so that's why it creates some kind of rift structure, and that leads to the division of two river systems. One river system will flow towards the north or maybe towards a different direction, and other will flow opposite to that direction. That is called your watershed. That is a river source. Tributaries, yes, you know, tributaries are the part of river system, but they are not the originated from the main source. They come from their respective sources, but after all they merge with the main system, main river system. Yes, main river. Distributaries, yes, same thing. If our river system following a single direction at any landforms, because of some barriers, they may go to a different directions. If they go to the different direction opposite to the tributaries, it becomes your distributaries. Yes, distributaries. And you know where river system drain off to the larger seas or larger water bodies. That is called your river mouth. Like example, best example is, yes, we have lot of delta basin also. Bay of Bengal, Godavari, Krishna. They form the mouth system, river mouth system. So we'll try to see everything in a very simple way. I'll not be very fast. I'll teach you in a very brief manner, in a very simple manner. The total area that contributes water to a single drainage system of river is known as the reverse drainage basin. What does it mean? The total area means the area under the river also, the area under the land also, that are related with the river system. River bank also, a river also. The total area that contributes water, because of that area, waters follow a single drainage system, become a direction. It gives a direction. Whatever land gives direction to the river system is called your drainage basins. In other words also, the drainage basin therefore includes both the streams, rivers as well as land surface. So simple. This is another definition. Drainage basin means you have streams, rivers and land surfaces also. And yes, it acts as a funnel. Yes, funnel. If you have funnel, you can put water in funnel and go at the mouth. So whether you put water from this side, whether you put from that side, after all it collected and go to the mouth side. So it acts as a funnel by collecting all the river within the area and channeling it to a single point. That means it gives direction. That's why it acts as a funneling. So drainage basin are the basins which consist of different kinds of streams, rivers as well as your land surface. It acts as a funnel to collect all the waters so that it channelize it to a single point or a single direction. And after some barriers, the single point may get distributed and form the lot of distributaries. Like tributaries, we can have distributaries also. Both are very opposite to each other. What do you mean by a term drainage divide? Yes, I told you. Adjacent drainage basins are separated from one another by drainage divide or watershed. Yes, you can say watershed, same thing. Adjacent drainage basins means nearby drainage basin, whatever you have, are being separated from one another. Means yes, we have a Indus drainage basin, we have a Gangetic basin. So due to the upland, due to the rise of the land from the mean sea level, it creates a divide, and our Indus will flow to that direction, and your river Ganga water will flow to east direction. So adjacent drainage basins are separated by one another by a drainage divide. The drainage divide is usually a ridge or a high platform or a mountain system that is responsible for creating river system in a two directions and form a two different river system. Drainage divide is conspicuous in case of hilly topography like the Himalayas, and it is not well marked in the plains like Ganga plains. Yes, very good point. Drainage divide is conspicuous in case of hilly topography. If you have a hilly topography, then we can see the more effect of drainage divide. More divide. But let's say what about the Ganga plain? In Ganga plain there is no high raised platform, so there will be no such a huge level of water divide. That's why, but it is not well marked in plains like Ganga plain. You can see with the help of diagram. First we have basin A and basin B. Okay, we have some drainage divide, maybe in the form of mountain. If water falls from the clouds, let's say, because of the raised platform, some water will go towards the east direction, some will go to the different directions, other directions, and it may create two streams also. Let's see watershed boundaries. Yes, watershed boundaries, same thing. We have basin A, basin B, and separated. Okay, this will be the most appropriate that I told you at the beginning of this class. Water divide, from river source we get a river, we get a source of waters, but due to the water divide, some waters will go to the different directions, or some will go to the opposite directions. Yes, from there, yes, tributaries also. Tributaries have their respective sources. Tributaries get accumulated or get collected in main river system, and after a certain boundary, after a certain barrier, this main river system get into the many distributaries, and finally they reach at the river mouth, where the river system met with your larger bodies. So what do you mean by same thing? Geometric arrangement of stream in regions get determined. How streams will follow the pattern? Which pattern river will follow? That all depends on certain factors like slope. What kind of slope do you have? Plain have a very flat surface, but mountain have very steep slope. So it depends on the slope. What kind of slope we have? Yesterday I told you about the Ajanta caves as well as your Ellora caves. That time also I told you, in Ellora caves we have a steep slope, but in Ellora caves, in Ajanta caves we don't have such kind of slope. So the direction of the river system totally depend on the certain parameters, and the first important parameter is slope. Second one is rock resistance. How much rock can give resistance? If rock is not giving resistance, what does it mean? River will flow. River will flow without having too much disturbance. And if rock structure is creating as a barrier, it will lead to the many distributaries also. That's why rock resistance to weathering and erosion. Third is climate. Yes, climate depends. In monsoon you have a lot of water bodies that flow on the bank of the river also. And fourth one is structural controls of the landscape. Are you building any dam on the landscape? If you are building dam, that means you are controlling the direction of the river system. These four are the very, very fundamental parameters that essentially lead or become important in order to decide in which direction your stream is going to follow the pattern. Second one, this kind of geometric arrangement of the stream is also called a drainage pattern. I will tell you today what kind of drainage pattern can we have. Dendritic, spiral, many kinds of drainage pattern we have. In other words, it refers to a design which a river and its tributaries form together from its source to its mouth. How river, how their tributaries emerge from their respective sources, and in which direction they follow, and how they merge with together, and how after merging, how they follow the directions. It's all about these things. Dainty drainage, you see, dainty drainage of your Brahmaputra river in Tibet is seen from the space. Yes, this kind of drainage pattern being followed by our Brahmaputra river that essentially emerge from your Tibet region, you know. Yes, we have lot of drainage pattern, like antecedent or inconsequent drainage. What does it mean, Komal? Antecedent means before any barriers. Open your ear, very very important. Antecedent drainage means before any physical barrier there was a river system. River system is not because of the barrier, because let's say you have an example of Himalayas, but there are a lot of rivers who come prior to the Himalayas. That's why it is an antecedent or inconsequent drainage, means it is a not result of something. It was actually a pre-existent. This type of drainage actually pre-existed in past also. So having barrier will not impact too much, because there was a general pattern that they used to follow in their past time also. That is an antecedent drainage pattern. Second one is consequent, because of the barrier, because of the Himalayas, they follow certain patterns. That is your consequent. Consequent means as a result drainage system. Subsequent means after having some structure, now water is emerging. That is a subsequent, after. Superimposed, what does it mean? Come together. I will explain everything. Dendritic, trellis, rectangular, radial, parallel and centripetal. These kind of drainage patterns one can expect from the river system. Yes, let's see the first. So you have beautiful diagram. Yes, there is your, let's say, antecedent drainage cuts through the tectonic. Okay, the river that existed before the uplift of the mountains. There was no upliftment of any mountains at that time, but river was pre-existent. River was formed before the mountain system. So the river that existed before the uplift of the mountain, and those that cut their courses southward by making deep gorges in the mountains are called antecedent rivers, because of the barrier. River used to flow in the past time also, when there was no Himalaya system, when there was no mountains. But after forming the mountains, river may changes their courses, but now they follow the pattern is called your antecedent drainage system, drainage pattern. But that river existed before the formation of any barrier, maybe in the form of plateau, maybe in the form of mountain, maybe in the form of Himalayas. Example of such rivers, Himalaya, we have many rivers like Indus, Satluj, Ganga, Brahmaputra. They are actually prior to your Himalayan system. Yes, they used to flow in past also. So after forming the Himalayas, they may change their courses, but that river was in past also, used to flow in past also, maybe in a different direction. So you can see with the map, with the diagram. Yes, we have see. Yes, there is a upliftment of land, so it creates a deep gorges. Yes, you have two Himalayan system. If you have two mountains, and in between you have a deep gorges, and the whole picture is called your deep gorges. The antecedent drainage cuts through the tectonic upliftment because of the upliftment of your land system. Consequential drainage pattern. Consequential, as I told you, because of the some structure, like the river which follow the general direction of a slope. Yes, you have a slope. That's why it has to follow a same direction. If I put water, if I pour water, water will go following the slope. Same, the rivers which follow the general direction of slope are known as the consequent rivers or consequent drainage, because it is because of the main sources, and the way they get the slope, they will follow the same pattern. Most of the rivers of the peninsula are consequent rivers, because you know Krishna and Godavari originated from the peninsula plateau, many river system, many mountains. You know, in plateau also we have a lot of mountain system, Amarkantak. Yes, from there it follows the general pattern because of the slope. We know our peninsula generally tilted towards east direction. So from west we have a drainage basin, we have a drainage pattern. So most of the rivers of Peninsula India are consequent rivers. It may be your potential question in civil service. Example, Godavari, Krishna and Kaveri. They are all consequent river system. Now you will see subsequent drainage. Subsequent drainage is here because of this thing. So after, subsequent means after. A tributary stream that is eroded along an underlying belt of non-resistant rock after many drainage pattern has been established is known as the subsequent drainage. A tributary system, tributary means one river will come from here, one river will come from and join the main river system. A tributary stream that is eroded along the underlying belt of non-resistant rock. The rock is not resistant, that's not creating a barrier. So river flow on the non-resistant your rock system, and a rock will not provide any kind of barriers. What does it mean? It means that a tributary stream that is eroded along an underlying belt of non-resistant after the main drainage pattern has been established. How is possible? You have a main drainage pattern and now your stream follow the direction towards the main drainage pattern. Because of having the main drainage pattern, because of the main river system, the way the main drainage system following the path, because of this thing, many river systems are coming and emerging and amalgamating themselves in the main river system. And the rocks through which they are cutting, they are also non-resistive in nature. They are not they are not providing any kind of resistance to them. So these kind of things are called your subsequent drainage. Okay, for that you need to have first your main river system, and after seeing the main river system, tributaries will follow the pattern, and after all following the pattern, after all it will emerge, it will divulge into your main river system. So simple. A tributary stream that is eroded along an underlying belt of non-resistant rock after main drainage pattern, any consequent river has been established is known as your subsequent drainage. In simple way, the streams developed after the development of original stream. So simple. Due to the northward slope of peninsula towards the Great Plains, you know, northward slope of the peninsula, like this, towards the Great Plains, means what? Northward, yes? Yes, of north, the river originating from the Vindhyachal Satpura ranges flow northward into the Ganga system, and they are said to be the subsequent drainage of the Ganga. Because of the, we have the river system, Ganga river system, and because tiltation towards your, there is a tilt towards your north direction. That's why some of the river system from the peninsula India go there and meet to the Ganga system, like Yamuna, like Damodar. And if you see from the upper side, you have a Kosi, Gandak. They are also a part of your, yes, Chambal, Sindh, Ken, Betwa, so on, are all the examples of your subsequent drainage. The subsequent means the original stream must be developed first, then other tributaries will follow the direction, whether I should touch with the main river system or not. Now very important, superimposed drainage pattern. Super, yes. First let's say, you know, land is subject to change. You know this thing. Over the period of time, land can be transformed into different structure. Let's see in first case, you have softer rock stratum, soft rock, but with the subsequent years, harder base rocks getting exposed by the erosion, and there was your harder surface on top of the land. Let's see. But despite of having, I repeat, despite of having harder surface on the harder rock on the surface, it will not prove barrier to the original direction of the streams. That type of drainage pattern is called superimposed drainage system. So simple. When a river flowing over a softer rock stratum reaches the harder base rocks with the passage of time, but continue to flow the initial slope, that means it does not change its position, it does not change its direction. It seems to have no correlation, no relation with the harder bedrock, no relation. They are following the same direction. Second one, this type of drainage is called superimposed drainage. Usually, the drainage pattern are strongly influenced. Usually, if you see naturally, it could have impacted by the rockiness that has been evolved over the period of time, but it could not impact it. If such happens, then we can say yes, it is a superimposed drainage. Usually, the drainage patterns are strongly influenced by the rockiness and the softness of the rock materials over which the river flows. But in this case, it will become your redundant. It will become useless, and the original stream will follow the same direction despite of having changes over the period of time on the surface of the land. However, in the superimposed drainage system, you get a situation where the drainage pattern does not correspond to the hardness or the softness of the bedrock. Irrespective of the nature of your bedrock, stream will follow the same direction which it used to follow in the past also, when there was no such structure present. Very, very simple. So yeah, you can see the diagram, beautiful diagram. Yes, in second case you see there is a lot of rocky structure created. In simple ways you can say that the river flows became independent of present day topography. Whatever present day topography may be in the form of rockiness present, but it flow independent of this barrier. It flow in its initial path without being influenced by the changing topography. Yes. Fifth point about superimposed drainage. In other words, it is a drainage pattern which shows disaccordance with the underlying rock structure. They are not consonant with the rock structure. Whatever rock structure you have, maybe either in the raised platform, maybe in the lower platform, it will not impact it in the direction of the river system. So disaccordance with the underlying rock structure because it originally developed on a cover of rocks that has now completely disappeared due to the continuous denudation. Because the pattern which river system used to follow in the past will follow the same despite of same thing. Consequent after, river direction related to the original cover which got eroded and the river have been able to retain. How it happens? Because of this, because this is a changing structure. Why changing structure does not affect the river stream? Because of the natural phenomena. Yes, you relate with the fifth point. In another word, it is a drainage pattern which shows disaccordance with the underlying rock structure. Because why is it so? Because it originally developed on a cover of rocks. Because the streams, because of the drainage. How drainage pattern developed at the initial stage? It developed on a cover of rocks that has now completely disappeared. Now it completely disappeared because of the overall period, because of the time, because of the denudation. Continuously after that, river direction related to the original rock cover. Again, after disappearing of the rock structure, stream tried to follow the same original path. River direction related to the original rock cover which got eroded and the river have been able to retain their original courses unaffected by the newly structure. Example, what is the example? Damodar and Subarnekra. Despite of structure, hard structure that has been developed over the period of time, but will follow the same direction, will follow the same route. River direction related to the original rock cover unaltered by the exposed structure. Same thing. Yes, dendritic drainage. What is the dendritic drainage? You know, our neuron is also dendritic. Neuron, our neuron system. I think you have read in class 10. Central nervous system. Hormones, chapter of hormones. Dendritic means the drainage system resembles the appearance of a tree, yet it looks like a tree, branches of tree. This is an irregular tree branch, yes. You know, we don't have such a regular, it must be like this, no, can't have such a structure. That's why it is an irregular tree branch shaped pattern. Dendritic pattern develops in a terrain which has a uniform lithology. Means what is a lithology? It is a land surface. So it will create such a, yes, I saw you, I have seen, you have seen about the Brahmaputra, Dendritic, Brahmaputra river system, yes. Most of the rivers of the Indo-Gangetic plains are your dendritic, follow the dendritic pattern. It resembles with the structure of your branches of tree. Now trellis drainage system, very different. It's very, very different. First I will try to relate with the diagram. Yes, let's say you have ridges of the resistant rock, ridges, and because of the ridges it may create the barriers, and depending on the ridges streams will follow the direction, obviously. Second one is a softer rock. Softer rock, what does it mean? It will not create hindrance to the streams, it will not create any barrier to the stream. So let's say one water is following, first one, and there is a ridge, and in between there is a gap. So the stream will cut at a 90 degree and meet the main river system. But if you see the two river systems, they are also parallel to each other. Main stream and your tributaries both are parallel to each other also, and cut at your 90 degree. Yes, Komal, any problem? So in trellis drainage pattern, we have a main river system as well as your tributaries. Tributaries run parallel to the main river system but cuts each other at 90 degree. That is called trellis drainage system. These are characteristics of folded topography. This kind of drainage pattern you will get from the folded topography. Folded because of folded, you will have resistant rock, you will have softer rock. Folded, different kind of structure, opposite structure of landforms. This pattern exists in nearly parallel mountains. Yes, parallel, we have parallel mountains. Yes, we have parallel mountains, you can see. Where drainage patterns are influenced by rock structure. Obviously, rock structure may be in the form of your ridges, resistant rocks, maybe in the form of your softer rocks. So, where drainage patterns are influenced by the rock structure of variable resistance or folded strata. In this pattern, the short subsequent stream meet the main stream at right angles, or we can say that tributaries flow roughly parallel to each other. Yes, I told you. Example, the folded mountains of Singhbhum in Chota Nagpur plateau have a drainage of trellis pattern. Yes, whatever we have, Singhbhum, Chota Nagpur plateau in Jharkhand, okay, because of the nature of mountains, folded mountains, it follows the pattern of trellis. Now we have a rectangular pattern, rectangular drainage pattern. Yes, you can see with the map. It differs from the trellis drainage pattern. Insofar, it is a more irregular. It is a more irregular, not a regular. And its tributaries are neither as long nor as parallel. Not long, not parallel. And it resembles with the rectangular structure. Not too much rectangular, but somehow can relate. Somehow it is related to your rectangular structure. A rectangular pattern is formed because of the faulting and the presence of excessive joint in a landscape. It is being developed because of the faulting. Faulting, you know, there is a fault, there is a gap between the two rocks, between the two structure. Fault because of the maybe some tectonic actions, because of faulting and the presence of excessive joint in the landscapes. This directs, because of the fault, because of the excessive joint, directs the stream in a pattern right angle turns, and that is the main stream bends at right angles and the tributaries join at right angles, creating the completely rectangular patterns. One tributaries meet at the 90 degree to another, and in this way it forms a rectangular pattern. Example, drainage pattern found in the Vindhyas mountain of India system. They follow the rectangular drainage pattern. Now we will see radial drainage, very simple. From the source, Komal, from the source, rivers, yes, from the source or from anywhere, water will go to the different direction. That is the radial direction. That is the radial pattern. The radial pattern drainage results from a stream flowing off a central peak or a dome. Yes, from a raised platform, it goes to all direction. It is a pattern characterized by outflowing rivers which drains down in all directions from a central point. So simple. Example is river originating from the Amarkantak mountain system. Follows this kind of drainage pattern. Now we have a parallel drainage and centripetal drainage. Parallel drainage, yes, is in which a river flows almost parallel to each other. That is called a parallel. So simple. Like example, river that originate in the Western Ghats like Saraswati, yes, Saravati in Karnataka, Talopa in Goa, and Periyar river in Kerala. All are parallel to each other. All are parallel to each other. Centripetal, yes, centripetal means, yeah, what? Centripetal is your, centrifugal and centripetal. Centripetal is always toward the center, and centrifugal is away from the center. Yes. In this pattern, the streams converge into a low-lying surface from all the sides, opposite from your radial direction, radial pattern. Here, all streams come together from different directions and merge at a single point. Example. Opposite to, yes, radial form, opposite, exactly opposite. Example, streams of Ladakh, Tibet and Bhagavati and its tributaries in Nepal. They all follow the pattern of centripetal drainage. Drainage system of India, yes, we have seen the drainage pattern of India. We have lot of drainage pattern, all are very important. Indian drainage system consists of a large number of small and big rivers, no doubt about it. It is the outcome of the evolutionary process of three major physiographic units and the nature and characteristics of precipitation. Some are perennial in nature, some are seasonal in nature, depending on the precipitation, depending on the sources from where they are originated. If they are originated from the Himalayas, they will be perennial. If they are originated from the other sources, they may be seasonal. It depends on the precipitation as well as the sources also. If a river flows from the Himalayas, we should expect that it will be a perennial kind of perennial nature. It will show a perennial nature. So it is an outcome of evolutionary process of three physiographic units. What is the three physiographic units, Komal? Himalaya, plains, plateau. Physiographic units, and the nature and the characteristic of precipitation. Monsoon, conventional rainfall system. Yes. Himalayan drainage system. First we will see Himalayan drainage system. Yes, actually we are starting the class from now. Himalayan drainage system has evolved through a long geological history. Yes, you are aware of this. It mainly includes the Ganga, Indus and the Brahmaputra. That's why plain is called Indo-Ganga and Brahmaputra plain. Yes, because this river system from east to west covered whole of this river system. Since these are fed both by melting of snow as well as precipitation, river of this system are perennial in nature. So simple. This river passed through the giant gorges because of the mountain system. It creates the deep gorges carved out by the erosional activity carried out simultaneously with the uplift. The way Himalayas are uplifting day after day, creating the deep gorges. So simple. This river passed through the deep gorges carved out by the erosional activity, and also carry the many sediments and deposit on the Ganga plain. Beside deep gorges, this river also forms V-shaped. Yes, you can see V-shaped structure. Yes, rapid and waterfalls in the mountain courses also. We saw jog falls in the Karnataka peninsula. Yes, it may create the falls also, waterfalls also. While entering the plains, they form the depositional features like flat valleys, oxbow rain. It is a kind of your oxbow lake formation. Yes, lake, very different lake. It is kind of oxbow lakes, flood plains, braided channels, and many deltas. It all depends on the direction of the river system. Last page. In the Himalayan reaches, the courses of this river is highly tortuous, but over the plains they display a strong meandering tendency. Yes, you know, in Himalayas we have Himalayas at the highest peak, so we get this kind of tortuous. Tortuous means what? They follow steep directions, steep slope. But in plain we don't have such kind of upliftment of the land. But over the plains they display a strong meandering. Meandering means, yes, to move like this. but in Himalayas can't move like this. So that's why, but over the plains they display a strong migratory tendency and shift their courses frequently. But in Himalayas you can't change their courses. And because of this, Kosi rivers become a sorrow of Bihar, Damodar river become a sorrow of, because of the land structure. Had it been there in the Himalayas, there was no problem, because Himalayas have a great mountains. You have to follow the certain pattern. You can't go for the meandering. For example, river Kosi, also known as the sorrow of Bihar, has been notorious for frequently changing its course because of the land structure. The Kosi brings huge quantity of sediments from upper reaches and deposit in the plains. The course gets blocked, and after blocking the course, the river changes its course and becomes sorrow for the other peasants, agricultural activities and so on. Yes, I have covered the first Himalayan drainage. In second module, we will try to see the peninsular drainage and other drainage system also. Yes, I have covered this module successfully.